Hello, this is part 3 of the transition metals topic, stereoisomers. Stereoisomers are molecules with the same structural formula but a different arrangement of atoms in space. There are several different types of stereoisomers. Cis-trans, also known as IZ if you're fond of German, it is present in both octahedral and square planar complexes. Optical, which is exhibited by only octahedral, as square planar complexes have a line of symmetry. And then there's also Merfak, but we're not going to be looking into those just yet. Here are some examples of cis-trans complexes with monodentate ligands. For square planar, we have cis and trans platin, which have different properties despite having very similar structures. Because of this, cisplatin can be used in cancer treatment, while transplatin is clinically useless, yet this does not excuse transphobia. Notice that for transplatin, the identical ligands are at 180 degrees to each other, while for the cis isomer, they are at 90 degrees. For octahedral, we have tetraaqua dichlorocobalt 2, and we can see the angle difference between chloride ligands. Now let's take a look at complexes with bidentate ligands. Here glycine was simplified to an O and acetylenodiamine to an N, as seen in the pictures. For square planar we have diglycinitoplatinum 2, and as you can see for cis isomer, nitrogens as well as oxygens are at 90 degrees to each other, while for trans, they are on opposite sides. The same can be observed with our octahedral example, dichloroacetylenodiamine nickel 2, if you look at the angle between chloride ion ligands. Now, to help you visualize the difference between cis and trans isomers, we carefully handcrafted these astonishingly beautiful molecules using a molecular model set. Please be aware that sadly this video is not sponsored by the UOB online shop. This is our cisplatin, which can be easily transformed to transplatin by swapping around chloride and amine ligands. This little fella is a nameless octahedral monodentate complex. The green balls are at 90 degrees to each other, therefore it's a cis isomer, and just like that it becomes trans. Now, here is a molecule that might as well be diglycinitoplatinum 2 in its cis form, and by swapping two ligands, it undergoes a magical transformation into its trans form. Here we have something that resembles a simplified cis-dichloroacetylenodiamine nickel 2, and it is quickly turned into its trans isomer. And now we will move to optical isomers, which are non-superimposable mirror images of each other and are referred to as enantiomers. These occur when a molecule doesn't have a plane of symmetry, and to show this we are going to reflect an already familiar to us cis isomer against a plane as shown on the board. We will also repeat this with triacyllenodiamine chromium 3 because confusing people is fun. Understanding optical isomers can be challenging, but to make it a bit easier, we created these charming 3D molecules. These two are clearly mirror images, but are they non-superimposable? Why yes, they are. Why else would we show them to you? Here are some questions for you to have a go at. Please pause the video and come back to it when you give up. The first molecule can have amines at 90 degrees or 180 degrees to one another, thus having cis and trans forms. The second one can also have cis-trans, and its cis form shows optical isomerism because of bidentate ligands. The last one only exists as its cis form due to bidentate ligands being unable to stretch far enough to be trans to each other. I would encourage you to try to draw this out to get a better understanding of where the answers come from. This is one time you are allowed to transvestigate, and my excellent transradar tells me that the first compound is cis, while the second one is trans, as seen by the angles. Bye.